All right, where we left. So we're supposed to calculate E net at point B. Like I said, we use F net at point B because in question number 2.2.3, we just calculated the net coulombic force at B. So we want E field, electric field now, not electrostatic force. We want electric field. So this is the formula that we use. Like I said, E is equals to F over Q, right? So in this case, we're going to use F net. You can also do this way, but that's a longer. This is only 3 marks, you see? So this worth 3 marks. Oh, before I forget the units. And then the units for this E net, let me just write the units. The units for this E net is going to be, remember, this is newtons per coulomb. Newtons per coulomb, this is charge, it's C. So the unit is going to be Newton per coulomb. This is the units. Make sure that you write the units all the times at your final answer. So I was saying you can also use this formula. E net is equals to KQ over R squared. You can use QA plus K over QC over R squared. You can also use this equation whereby you're going to say electric field for this plus electric field for that. You can also do that. But you're gonna have to be careful because you're gonna have to use Pythagoras theorem when coming to this one. But this is the simpler way to perform your calculations on this question. Now let us continue again with another question. Question number 8. And it reads as follows. It says to us, two identical point charges X and Y. These are identical charges apparently, are placed 2 millimeters apart. Point P is 3 millimeters to the right of charge Y. The net electric field at point P is given by 5,44 times 10 to the power positive 6 Newton per coulomb to the left. So at this point in time, we are given E net, the net electric field at point P. So this E net, it is given by what? This E net, it is given by this charge and that charge, hence why we're saying E net. So electric field of X and P plus electric field of Y and P, it will give us an E net. So that means E net, it's given by electric field of XP plus electric field of YP. This E net is given by this formula. Okay. The other thing, if you have a look at this, if you have a look at these questions, they are different. Here now we are dealing with charges that are placed linearly. They are on a straight line. They are no longer 90 degrees to one another. Here it's linear. So you just add. You don't have to use Pythagoras theorem in this case. But now the magnitude of this E net, they say to us, it is given by how much? So here direction is important, left or right. Because when you add EXP to EYP, it's either EYP is negative or both of them, they're negative. One is, it depends. So here direction is very important, whether to the left or right, and whether you substitute your negative or positive. There, those negatives, positive, they do not matter on the previous questions. So here E net is given to be how much? It's given to be 5,44 times 10 to the power of negative 6 Newton per coulomb. And then they say to the right, they say to the left, let's take left to be negative. So that means here we're going to get negative answer. If we choose left to be negative, most definitely. Again, one thing that I do not like, you also know it by now. Millimeters, we convert them into meters. So how to convert millimeters into meters? I think we divide by 1,000. Yes, we're going to have to divide by 1,000. Yep, we divide by 1,000. So we're going to say 2 divided by 1,000. You can also do that. King Henry died what. So here we're going to have 0,002 meters. Same applies to here. We divide by 1,000. We're going to have 0,003 meters. I hate this already before I even perform my calculations because I don't want to make mistakes. That's why. Now 8.1, it says to us, define the term electric field at a point. Electric field at a point. Electric field. Look, if I have a charge which is negatively charged, these lines over here, they form what you call the field lines. So this is the field of this charge. So electric field of this is given by the field lines of this charge. Okay, so this is the point that we are talking about. At this point, and do not forget, the electric field becomes stronger towards the center. But as we move radially away from the center, field line becomes weaker, weak. But here it is stronger. Here it is stronger compared as I move outwards. It becomes weaker, the field. So what is the term electric field at a point? 8.1, you say, it's 8.1, right? It's the electrostatic force experienced what have I done now? Experienced per unit positive charge. Normally, you can just, by simply saying placed at that point, or you can just end here, placed at that point. You know what, ne? If this is a field for this charge, if I place a positive charge next to on the field of this charge, if I place this guy says, okay, I understand, I am negatively charged, so I created the field around myself. I have field. This field is called electric field. So anything that comes around my field or close to my field, he or she is going to experience the force. So because positive is here, that means when positive detects the field of this guy, positive will go towards this guy, will be attracted towards that guy. So that's why we're saying the electrostatic force, because if this positive it is placed next to here, there will be electrostatic force between positive and negative. So that's why we say the electrostatic force experienced per unit positive charge placed at that point. You see, placed at that point. Okay, that's how we define it. And therefore 8.2. 8.2, it says, are the charges negative or positive? Which charges? X and Y. Remember, they are identical, okay? If X is negative, that means Y is also negative, and they have the same magnitude. To remember that. So are the charges negative or positive? Now, this is what is happening. Before you can answer negative or positive, you do not just guess. If you say negative, I might as well ask you, why do we say it's negative? If you say it's positive, you see, so you need to understand. So let me give you the answer. For 8.2, the charges are negative. Obvious, someone somewhere somehow is asking himself or herself, why do you say it's negative now? This is the reason why they're negative. Remember, because you're not given, right? Remember, we are given E-net. E-net is the one that's going to help us to see whether these charges are positive or negative. Remember, we are given the E-net. Now, we are given the E-net at which point? E-net at point P. This is a point charge. A point charge will always be positive, okay? And its magnitude is 1. So this point charge in this case, it is always positive. That's what we must know by now. So a point charge, when it sees these two charges, remember they are the same. A point charge, when it sees these two charges, where is it going to move? But because we are given that the inert, it is going to be directed towards the left. So that means the point charge is going to move towards the left of y, towards the left of x. You understand? So for a fact that point charge it is positively charged, that means these are negatively charged because they're gonna attract the point charge which is always positively charged. So for a fact that inert is towards the left, that means inert is given by, like I said, inert is given by E of xp, which is negative, E of yp, sorry, let's start here. E of xp, we have x, we have p, is gonna be to the left. That's going to be negative. E of yp, we have y, we have p, and then it's going to be towards the left. This one's going to be negative. So negative and negative, they're going to give E to be negative as well, E net to be negative as well. So that's why we say these charges, they are also negative, they are negative, both of them. Are the charges negative or positive? Negative. So what helped me? I used the sign of E net. And I know that this is a linear, I add to determine my inert, meaning negative plus negative is going to give me negative. That means it's towards that. Electric field is also a vector quantity, okay? Right. That will be 8.2. Now 8.3, it says to us, draw the resultant electric field pattern for charges X and Y. So here the one electric field pattern, you know what's the drill. So draw the resultant electric field pattern for X and Y. So now X and Y, when they see each other, we have determined that both of them are negative, right? So the negative charges, they always repel. Sorry. So here we have X, which is negatively charged. And then here we have Y, which is also negatively charged. So the field lines, they can't move from one point to another because they are both negatively charged. They're going to have to repel each other. So this and this, remember you use your ruler on these sides, okay? And therefore here, I use my ruler, and therefore here I use my ruler. Here I use my ruler, and here I use my ruler so that they act perpendicular. Now here's the thing, because it's a force of repulsion. So it's gonna be something that looks like this. This repels with that one. This repel with this one. And then even these lines, they're not gonna be straight. They're gonna be tilted a little bit like this. Same applies to here. Same applies to there. Same applies to there. This one is gonna be a little bit. And this one's gonna be a little bit. This one is gonna be far a little bit. And then this one's gonna be far a little bit. Now remember, now what's next is the arrows. Remember, for negative is towards the center. So that means when I just draw your arrows towards the center, all the times for negative, towards the center, towards the center. Then here it's going to be towards the center, towards the center, towards the center, towards the center, and that. Therefore, this will be your final answer for the electric field pattern for charge X and Y. Now we move to 8.4. Now 8.4, it says to us, calculate the magnitude of charge X for 5 marks. That's a lot. So now we want charge X, but what do we have? That's the question. In order for us to determine the magnitude of charge X, is the same as to calculate the magnitude of charge Y because they are identical. So I have E net instead, right? I have E net. So the formula to calculate E net in this case, I do not have F net. So I'm not going to use that formula that says E net is equals to F net over Q of P, of point P. Q of point P is always 1. By the way, point charge, its magnitude is always 1. So I'm not going to use this formula. So that means which formula I'm going to use? The very same one that I just drew here before. So that means it's going to be E of XP plus E of YP. So now, remember, E of XP is negative because P, when it sees X, it's going to move towards it. Remember, this is negative. Point charge is always positive. It's attraction. Point P will always move towards X. So that means I'm going to say I have negative. How to calculate electric field of X and P? It's going to be Q multiplied by Q. I'll just write Q for QX, okay? Or I can write X, but I'll just write Q divided by R squared. Plus, this one is also going to be negative as well. And then I'm going to say K. Also, I'm going to write Q because this Q is the same as that Q. So that's why I didn't want to write QX and QP because they are the same. I'll just write Q over R squared. Now, E net, it's negative how much? It's negative to the left, 5,44 times 10 to the power of negative 6. Now, Q, I'm going to take Q out as the common, I'm going to take KQ as a common factor. So I have KQ. And therefore, here I have negative 1 over R squared. Subtract 1 over R squared, and then I close my bracket. Here I have negative 5,44 times 10 to the power of negative 7. Now let us do substitutions then. So here I have negative 5,44 times 10 to the power of negative 7 is equals to K, it's Coulomb's constant, which is 9, times 10 to the power of positive 9 multiplied by Q. And then in my brackets, I have 1 over, what is R2? This R2, remember, is between X and P. So let's go between X and P. Between X and P, our distance is going to be 0,03 plus 0,02. We add this distance between X and P. We add 2 and 3, it's 5. So that means it's going to be 0,0055 to the power of 2. Subtract 1 over, and therefore now the distance between Y and P, Y and the P, it's here, it's 3 meters. So meaning it's going to be 0, I do not have space. Let me do this. Okay, I can just negative 5,44 times 10 to the power of negative positive 6, which is equals to 9, it's not s 9, and therefore here we have Q, and then here we have negative 1 over 0,005 to the power of 2, subtract 1 over 0,00, we say this 3 to the power of 2, close my bracket. And therefore, I'm going to left with Q this side. I'm going to divide by this. I'm also going to divide by this fraction to this number, just to do everything, or you add this on your calculator. Okay, let's do it. However you want to do it mathematically. So I'm going to start with this one. I'm going to punch this in my calculator. I'm going to say negative fraction 1 over 0,005 to the power of 2, subtract 1 over 0,003 to the power of 2. In my calculator, I get negative 15111, and then the very same answer that I got from here, I'm going to multiply it with 9 times 10 to the power positive 9. I'm going to multiply it with 9 times 10 to the power positive 9. I get negative 1,3 something. And that answer I got, I'm going to press my AC, and I'm going to say negative 5,44 times 10 to the power 6 divide by answer that I got before, and then I get that my Q, it's a but let's convert that, let's write it into scientific notation, and then my Q becomes 4, it's nanocoulomb, 0 times 10 to the power of -9 coulomb. So this is nanocoulomb. So I get my Q to be equals to this. Okay, but remember they say to us, it was 8.4. Calculate the magnitude of the charge X. So X will be equals to 4 times 10 to the power of -9 coulomb, or you can even write it like this, 4 nano coulomb, because this is to the power of -9. That's how we got our answer, okay, for 8.4. Now, 8.5, it says to us, charge Y is now replaced by an identical oppositely charged point. So that means charge Y. Remember, here we had, this was what is happening initially. Say here we still have X, and then now I'll call this charge Z, okay, charge Z, and then here we have point charge, which is still P, but because charge Y, it was negatively charged, so that means now this will be positively charged, and this, it is still 4 as well, it's still 4 times, sorry, it is still 4 times 10 to the power of -9 coulomb, as much as here we maintain that negative, which is 4 times 10 to the power -9, because they said charge Y is now replaced by an identical oppositely charged. It's no longer negative, it's positive. Now, how will the magnitude of the net electric field at point P be affected? That's the question. This is what we got initially. This is what we had initially. But if we have this story, by just altering Y with the Z, the difference is here was negative, now here it's positive. What's going to happen with this? You know what I love to say, né? When it comes to questions like this, you can prove it, you can calculate it by yourself. How will the magnitude of the net electric field at point P be affected? Is it going to increase, decrease, or remain the same? Give a reason for the answer. You can calculate it just to confirm whether it's going to decrease or increase or remain the same. But you don't even have to do that, man. You understand these things. Now, the thing is, the magnetic field will decrease without calculating. Why? I mean, like, think of physics, think of vectors, think of all of those things. They're supposed to make sense in your head, okay? The reason being, let me write it down. The positive, né? The positive charge on X will have what? Will have field in the opposite direction. Ne? The electric field strength will decrease. Will decrease because of opposite direction. Here's the story. This is the final answer. Ne? Here's the story. Let's discuss this. The positive charge on X, remember, this positive charge on this X, the positive charge on X will have field in opposite direction. Remember here, this had the field in the same direction. P was moving towards X. P was moving P was moving towards Y. P was moving towards X. But now here, P is moving towards X. Now here, remember P is always positive. P will move away from Z. Here's the thing. If here it's 5, and then here it's 10. Let's say here, it is still 10 because it's from P to X. P to X, it is still 10. And then here, away, because everything's the same, is going to be 5. But you have to account here, they move in the same direction. So for a fact that they move in the same direction, it's going to be 5 plus 10. It's going to give you 15. Here, for an example, it's moving to the left, it's going to be negative 10. This one is moving to the right, it's going to be positive 5. So it's going to be negative 10 plus 5, we get negative 5. We don't care about the negative because remember, negative and positive, they tell us the direction, not the magnitude. I understand negative 5 is less, but we are not looking at the sign as a form of magnitude. Sign, it gives, in physics, you need to know that, guys. Sign gives directions, not the magnitude. So it's not negative 5, this thing is 5. Yes, it's negative because it means left. So meaning, we're going to compare the numbers 15 and 5. What's happening? 15 is greater than 5. Why is 15 greater than 5? Because this was the story. Y was negative, but when Y, it is replaced to be positive. Now, what is happening with the electric field? The electric field decreases, it becomes 5. So the positive charge on X will have field in opposite direction. The electric field strength will decrease because of opposite direction. So this is true. You can also explain it in this way. That's why we say the electric field will decrease when we have the positive charge, which is this 1. Now the field will decrease to 5. That's why I'm saying you can calculate it to see it will make sense. So that's it for this video.